Hi chemistry class, time for another lab. So today we're going to be looking at the types of chemical reactions lab. For this you're going to need to have the file open. You can print it out if you have that capability. Otherwise you can just fill it out as you watch this video. I'm going to do the labs in order following along on the sheet, and you can just fill in and answer the questions as we go. Okay? All right. So for our first lab, we're going to be looking at the decomposition of hydrogen peroxide. Hydrogen peroxide's formula is H2O2. This is hydrogen peroxide. That's really the only thing reacting in this lab. The rest of this over here is just to kickstart the reaction. Potassium iodide is to kickstart it. And soap is just so you can see the reaction because it'll be more fun. You might be familiar with peroxide. You probably have some at your house. Maybe it looks like this. Okay, it's something you commonly would have in your bathroom. People use it a lot of times to treat cuts. This peroxide that you have at your house is a concentration of 3%. This peroxide that I'm going to use for today's lab has a concentration of 30%, so 10 times more concentrated. This stuff would work for the lab, but it wouldn't be as exciting. We're all about exciting in chemistry, so we're going to use the more concentrated. Okay, so our directions say to measure out 5 milliliters of potassium iodide. That's this solution here. And I'll put that in a graduated cylinder and just set it aside. Okay. So potassium iodide is something called a catalyst. It kick-starts the reaction, just gets it going, but it's not actually what's being reacted. So hint, hint, the question there, do you include that in the chemical reaction? No, you don't, because it's not in the reaction. Okay, in our 50 milliliter graduated cylinder here, we are going to measure out, well, we're just going to add a little bit of dish soap. Again, like I said before, it's just for effect, just something to make you see the reaction better. Then it says here, I'm going to measure out my peroxide. I'm going to use 10 milliliters of the hydrogen peroxide. So I'll measure that out into my graduated cylinder here. Alright, that'll be good. Just cover back on here. This bottle is an accordion bottle like this because hydrogen peroxide actually decomposes when it's on the shelf by itself, so it has to have room in the bottle to expand. Alright, then I'm going to add my 5 milliliters of potassium iodide to kickstart the reaction. Okay, and we'll just see what happens here. Okay, you can see it foaming up. There was quite a bit of color change. There's a whole bunch of heat being given off. The bubbles in that are actually bubbles of oxygen gas because when hydrogen peroxide breaks down, decomposes, it gives off oxygen gas. Also think about what you'd have as a product, or what you'd have if you were going to make soap bubbles like that at home. What other substance would you use? You would use soap solution and a whole bunch of water, of course. So the other product of this reaction is water. Lastly, since this reaction gave off a whole bunch of heat, heat was exiting our system, right? So we would call this an exothermic type of reaction. All right, so to finish this up, you're going to write your balanced equation. On to our next reaction. Okay, for our next lab, we are going to be looking at the reaction of copper metal with air. So I have here a piece of copper sheet. And the Bunsen burner is going to give us just kind of another kickstart to get the reaction going. The copper is going to react with air. Now think about the element in air that the metal is going to react with. My hint on your sheet there is that sometimes when metals react with air, it's called oxidizing, because think of what element that is that it's reacting with. All right, so you can look at the copper before the reaction. You see it's shiny, okay, copper colored, kind of that orangey color. So we're going to heat it in the Bunsen burner flame. So light my Bunsen burner here. I'm very sad you guys aren't here to play with the Bunsen burners. Okay, light my Bunsen burner, adjust it so that I have that nice blue cone. Video. Okay, nice blue cone. Okay, and I'm going to take my piece of copper metal here, and I'm going to heat it in my Bunsen burner flames. Ooh, look at that pretty flame we get. If you remember flame testing, when we had copper solutions, what color did they turn? Green, right? Okay, so we're going to heat our copper a little bit. Okay. Now, as you're watching this, the green flame is a nice sign of a chemical reaction, but we also have here, look at what happened to our copper metal after we heated it. You see how it looks now? Much different from what it looked like before. Okay, so you have some signs of chemical changes right there. So our metal kind of stuck together with the oxygen from the air. And when I say stuck together, I mean formed a chemical bond. So it formed a chemical bond with the oxygen from the air. Okay, so think about that when you're writing your balance equation for this lab. Okay, for our next lab, we're going to be looking at the reaction of ethyl alcohol with oxygen, which is again readily available in the air. So we're going to take a little bit of our ethyl alcohol and pour it into our petri dish here. I'll recap that. Okay. So what we're going to do is observe what happens when a little bit of energy is given to the ethanol and the oxygen. So the ethanol is in this petri dish. Oxygen is just in the air all around us. Okay. So you can see some clear signs of chemical reactions going on there. And this, of course, is one that's burning, so we should pretty easily be able to figure out what kind of reaction that is. Okay. When we're done observing this, I'm just going to take the cover here and cover it up, and the reaction stops. It goes out. Even if I took the cover back off, right, the reaction has gone out. So think about what I took away from that reaction, which of the reactants I eliminated, and why that reaction stopped. So now you're going to write your balanced chemical equation for that reaction. The formula for ethanol is up on the top there. Remember the oxygen that you're using in your equation. Oxygen is a diatomic element, so that should be O2 that you're including as part of one of your reactants. Okay, time for our last lab. So lab 4, you're going to be looking at the reaction of an acid and a base. So we have our acid here and our base here. They're both clear liquids. They both look like water, but they're both not water. All right. Anyway, so one is hydrochloric acid, and the formula for that is HCl, and then the other one is sodium hydroxide, and the formula for that is NaOH. Okay. Both of your reactants have partners, right? So think about that. They're not alone. They have a partner. Okay. So if you're going to record some observations, number 2 there, of your reactants, write down what they look like. Okay, for a procedure, I'm going to mix a small amount of hydrochloric acid with some sodium hydroxide and observe our reaction. Okay, since only one of these is done, we're going to do a bunch. Okay, so we have here, what do you think's happening? Oh. You've seen this before, because it's a good classic, one of my favorites. Okay, so you have here, there's your reaction. So what's your evidence that a chemical reaction has occurred? It should be pretty obvious to you. So you're going to write your balance equation for this reaction. Make sure you identify the type of reaction. Think about the fact they both had partners to start with. Both are going to have partners at the end too. Little double date swap there. Okay, after you've written your balance equation, look at what your products are. And you should be able to see why it's completely safe for me to know that I can pour this down the drain. Hope you guys enjoyed that lab, the couple of series of things. I know we can't do a lab in person, maybe someday, but hope you guys enjoyed that. Please let me know if you have questions. Miss you guys. Bye.